All right. Well, greetings again. This is Manish Gupta, founder and CEO of ShiftLeft. Thank you, everyone, for dialing in to our ShiftLeft's first webinar. Of course, as you can imagine, we are super excited to tell our story, why we started ShiftLeft, and how we are rethinking cloud security. But before I do that, let me just do some quick introductions and sort of set the agenda for the webinar today. As I said, this is Manish, and here with me I also have Vlad Ionescu, who's a co-founder and chief architect of ShiftLeft.
Hi, everyone.
So look, I see a lot of familiar names in the attendee list, so thank you again. Those of you who know me know that I've spent now a number of years in security, FireEye, Cisco, McAfee, and I think it was early last year when I was at FireEye, and we were still seeing 100,000 pieces of new malware a day. That caused me to sort of take a pause and ask myself, what the heck have I been doing for the last 15 years? We were in the business of detecting viruses, then it became worms, and then it became modern malware. But neither the pace nor the complexity of malware seems to be going down. Yet the pace of change in software is through the roof, and we'll talk a little bit about that. And it became clear that if software needs to be the engine of innovation across industries, then we have to rethink security. We have to come up with a way to protect software without constantly reacting to threats. And that is the mission at ShiftLeft, and that is what we will talk to you about today. The way we're going to spend the next hour is we will probably talk about the slides and the content therein for the first 20-25 minutes. Then Vlad will do a demo, which will take another about 15 to 20 minutes. So we will have a good 15-20 minutes at the very end for you to ask us questions. Of course, if there are any questions that come in the interim, please just jot them down in this GoToMeeting interface under questions, and that way we will continue to keep track and answer these questions as they come up towards the end. Awesome. Well, with that, let's start digging into what is ShiftLeft and some of the relevant details here. I'm sure all of you or several of you work in industries where you're seeing software increasingly moving into the cloud. Gartner calls it the next big disruptive trend since the dawn of the digital age, which is the movement of software into the cloud. As the software moves into the cloud, there are several things that happen, but one of the key things is the constant pace of change. And this pace of change inherently defeats traditional security tools. Because think about it, all of our security tools that we've been used to using, firewalls, intrusion detection, intrusion prevention, antivirus, web application firewall, vulnerability analysis, and the list is endless, either require us to write rules on our own, or at the most require us to tune these tools to our environment. But if the software is changing ever faster, we are working with some customers who are upgrading their microservices 50 times a day. That pace of change is not something that the traditional security tools were built to deal with. And so at ShiftLeft, we have come up with an approach that protects software from attacks and data leakage by embracing change. A little bit about ShiftLeft and the team. You see me in the middle, top row. The guy on the right, Chetan Konecki, he's our co-founder and CTO. Super smart guy. He recently was at Cloud Physics and was their chief data officer. You just heard from Vlad. In the bottom middle, you have Fabian Yamaguchi. Fabian is our chief scientist, and he's one of the foremost authorities in the world in the area of code analysis. He has come up with a very novel way of converting source code into a graphical representation that he calls code property graph. It is this that allows us to analyze code very quickly and very accurately. Bottom left is Eitan Lightstone. He's our VP of Design. Eitan most recently was the VP of Design at New Relic. As you will see when Vlad shows you the interface of the product, that user experience was something that was very important to us. And so from day one, we have envisioned an interface that minimizes friction and minimizes the time that it should take a customer to understand what's going on. Last but definitely not the least, upper left is Priya Chawla. She's a director of products. We raised our Series A from two venture capitalists, Bain Capital and Mayfield, early last year. And so we have great partners in Enrique Salem, of course, the CEO of Symantec for close to a decade, and Ushit Parekh, who represents Mayfield on our board. But one thing about the team I'll tell you is when we were thinking about this problem of how to protect software that is increasingly moving into the cloud, I spent a bunch of months working with some of my ex-security friends, and we could never come up with an approach that worked. It was only when I met with Chetan and Vlad, who come from a very different world, who come from cloud native, who come from data center, who come from the modern CI/CD, continuous integration, continuous deployment environment, were we able to look at both sides, which is code development and production environments. And that is crucial ingredient to be able to think or rethink rather security for cloud-based workloads. Look, I think we live in a very exciting times, we live in exciting times. Software underpins innovation across many industries. It's redefining several aspects of our daily lives. I was reading Satya Nadella's recent book, who talks about how every company is becoming a digital company, largely because, yes, software is driving innovation. Here we're talking about a car, but hospitality industry, healthcare, genetics, everything is being driven by software. And one of the key reasons why this is happening is because the software moving into the cloud, which allows us to innovate ever faster at an ever cheaper cost of investment. And therefore, it is no surprise that 41% of the workloads are already in the cloud, according to 451 Research Group. So this pace of software moving into the cloud and becoming SaaS, software as a service, is unrelenting. And this is a good time to sort of ask ourselves, why should we rethink security? Why is it that the traditional security tools won't work? And why is it that the traditional security tools were focused on threats? So here, we give you a representation of how the software industry has been the last 25 years. We call it the shrink-wrapped software industry. And we do that because, think about it, in the left side, you see companies like Microsoft and Oracle, who developed software, let's say Exchange and Oracle CRM respectively. These guys had access to source code, but then they shrink-wrapped it onto CDs and shipped it to customers around the world. To us, we deployed the software in our data centers. But notice that we did not have access to the source code. We could not look inside Microsoft Exchange or Oracle CRM to find out what its weaknesses are or how it should be protected. We had no choice but to treat this software as a black box and therefore protect it from the next best thing that we could understand, threats. And that has been the reason why the security industry has evolved the way it has. We protect these applications, Oracle CRM and Microsoft Exchange as examples, from viruses using antivirus, from intrusions using intrusion detection and prevention, from modern malware using sandboxes, i.e., in the world of shrink-wrapped software, the fundamental disconnect between where the software was developed, Oracle and Oracle and Microsoft in this example, and where the software ran, your data center, our data center, forced security to be focused on threats. And this is what changes with software moving into the cloud and being sold as software as a service. Notice now that the SaaS vendor is both responsible for developing the software, bottom left, as well as hosting the software for the consumption of its customers. For the first time since the dawn of the digital age, the onus of protecting the software falls on the same company that develops this software. And that was the aha moment for us to say, well, why then should we constantly react to threats in protecting the software in production? Why, instead, should we not understand the security requirements of the software itself? And that is precisely what we do at ShiftLeft. To sort of double click on this a little bit more, so on the left-hand side, you have the world of shrink-wrapped software. Remember, let's just stay with the same example of Microsoft Exchange. You deployed it in your data center. This was your data center. So you own the network. You own the server. You own the operating system on that server. But you didn't own the application. You only had a license to it. And so you focused all your energies, all of your security dollars went in protecting the network, which is why you bought the firewall. It went in protecting the server, which is why you bought intrusion detection, intrusion prevention, you bought antivirus, you bought server-side whitelisting, but you treated the application as a black box. You had no choice. But as the software moves into the cloud, let's say AWS or Microsoft Azure, now we're talking about a SaaS company, and all of us are becoming SaaS companies. As we are deploying our software in AWS and Azure, notice that you and I, we don't own the network anymore. It belongs to AWS. We don't increasingly own the server or the operating system. That is increasingly owned by AWS and Azure itself. What we own is the application. And so this is a fundamental shift in how security used to be done, focused on protecting the network and the server, and how security needs to be done in the world of SaaS, i.e. focus on application. And you don't have to take our word for it. AWS and Azure and Google Cloud all talk about this concept of shared responsibility model, where they are reinforcing the same thing and educating their customers that let me, if I'm AWS, let me worry about protecting the network and the operating system increasingly as they're going from infrastructure as a service to platform as a service. The onus of protecting the application and the onus of protecting the data within that application falls on the company developing that software and deploying it in the cloud. So hopefully by now we've convinced you as to why going forward, as software moves into the cloud, the thing that we can control, the thing that we have to protect is the application itself. So let's talk about how does ShiftLeft do this. Remember, one of the things that we laid out for ourselves was not to react to threats. And so in our world, we don't write a single threat-based signature. So how does our product work? So on the left side, you have your software development lifecycle. And because of the pace of innovation, your developers and DevOps are collaborating, and you are perhaps developing 1, 2, 10 versions of a particular microservice a day. This is a very different world. Developers can develop very quickly, and the racking and stacking of servers and plugging of network cables has been translated into scripts. And so all of this process is automated. This entire continuous integration, continuous deployment lifecycle is automated, which is what allows companies to innovate ever faster. We at ShiftLeft insert ourselves into that very fast, agile CI/CD lifecycle. And Vlad will actually show this to you through a demo. As we insert ourselves into the CI/CD lifecycle, every time the software changes, every time the microservice changes, or if you want to call it a workload, every time a workload changes, we extract its security DNA. Think about security DNA as everything that is security relevant in your piece of code, and we will double click on that in just a minute. We extract the security agent, and then informed by that security agent, we create a custom policy that informs a micro agent of the weaknesses that are in this version of this software. As a result, the micro agent protects this version of software surgically and precisely against its attack surface, not reacting to threats. So of course, the big question, the million-dollar question is, what is security DNA? So on the right side, we talk about the security DNA consists of what does the software do? And therefore, what does it not do? So as an example, and this is worth mentioning, look, we are not monitoring the behavior of the application. This is all done based on source code analysis, right? The one single source of truth, which is the software, the source code itself. And so if, for example, we understand that this particular microservice does not fork a process, and we find the application in production to be forking a process, we know that it has been exploited. And notice we get to do this without writing a single threat signature. We identify all the open source libraries, dependencies that are being used by this piece of software. Clearly, in today's world, and this trend is going to continue to grow, the software is increasingly being assembled because of the plethora of OSS available out there. But just by understanding what open source software a particular piece of code is using is not sufficient. What is equally important is to see how the application is using the OSS library and whether that usage will cause contextual vulnerabilities. And that is what we do at ShiftLeft. We understand the vulnerabilities in this software, and we do not rely on any third-party CVE lists or an NVD database. We do code analysis of our own. This goes back to the very onset of the discussion. I talked about how we use Fabian's code property graph approach to extract all of this information very accurately and very quickly. We understand all the sensitive data being used by this piece of code. Look, today, the state-of-the-art data leakage prevention tool is largely a network-based construct and will perhaps look for a 16-digit numerical value on the wire if it can actually see it by doing perhaps man in the middle if the traffic is encrypted, and then call it a card number. We, on the other hand, are focused on identifying through a patent pending algorithm all of the important variables in your source code. And then what we're really good at is understanding how that data flows. So we can therefore tell you very important conclusions such as, I see this credit card number being written to a third-party API without encryption. And if you choose not to fix it, we will detect it and prevent it at runtime. And finally, broken coding practices. We are asking a lot from our developers when we ask them to do 20 releases a day. So it's obvious that they are going to make more mistakes. One that we've read about in the recent past is hard coding credentials or hard coding keys. They were perhaps done for debugging purposes, but people forget to comment them out, and now they're running in production. It's these kinds of problems that are almost impossible to find today unless they actually happen in production and someone is monitoring production environment for that. We at ShiftLeft will tell you based on code analysis that this is a mistake. And if you choose not to fix it, we will detect it or prevent it in production. So I like to say at ShiftLeft, we are giving you an approach where for the first time in the world of security, you get to have your cake and eat it too. One of the things that I didn't talk about on the left side is as we extract the security DNA, we create the policy and the micro agent is then surgically protecting your application. We do this all in 5 minutes or less. Meaning every time your software changes, every time a microservice changes, we do this entire value chain in 5 minutes or less. So we are purpose-built for an environment that is increasingly doing more releases, perhaps 20 today and maybe 30 a year from now. With that, let me pass the ball to Vlad, who will actually show you how all of this works.
All right. Thank you, Manish. So I'm going to walk you through how you onboard ShiftLeft and get value from it in your own environment. So we're going to use a test application and show you how you integrate your test application with ShiftLeft and get the agent to report information in a UI that you interact with ShiftLeft directly. So it might be pretty obvious that the two integration points that we have are, first of all, getting the source code itself, and second one is installing the agent in production. So I'm going to show you both of these integration points and how easy it is to just get started. Let me just quickly start up a few things. All right. So this is Jenkins. You might be familiar with this interface if you are DevOps. So this is the tool of trade of every DevOps engineer. It allows DevOps to automate their builds and the way they deploy things in production. We have developed a plugin for Jenkins that allows you to upload the source code of the application to ShiftLeft for analysis every time you change your code. Let me just show you how easy it is to install it. You just go to Manage Jenkins and then Manage Plugins. And then in the Available tab, you can just look for ShiftLeft and install it. On this system, we already have it installed, so it shows up actually in the Installed tab. But all you have to do is tick the checkbox and then click Install, and you're done. Now you have the ShiftLeft plugin installed in Jenkins. And so the next thing you would do is configure it. To configure it, you go again, Manage Jenkins, Configure System, and this takes, okay, this was fast actually. And then in here, you look for ShiftLeft, and you have the upload configuration in here. These are things you configure using information you get from our website. So after you register, you get this information to add to your ShiftLeft Jenkins plugin installation. This is pretty standard, almost like a username password kind of thing. it allows the system to encrypt everything you upload to the ShiftLeft cloud. So that's about it. At this point, you have the ShiftLeft plugin installed. And so the next thing you would do is enable it in one of your projects. And so we have enabled it for one of these test projects here. And if we go to the latest run, we can see the outputs of this particular run of the ShiftLeft Jenkins plugin. So immediately you see this, these log lines telling you that the ShiftLeft Jenkins plugin has triggered. And so in this case, it's automatically detected the build type. It's saying it's a Maven type of project. It detected the jars automatically as resulting from this build. And then it uploads them. If you scroll down, you also see this particular dependency tree. As part of the upload, we also upload the dependencies themselves too. And so while we analyze the application itself, we also analyze all of the dependencies that make up the application. So from first principles, we can detect whether any open source software is misused in any way. And we alert on that. This process is done very, very fast in parallel, and it's under 5 minutes. So for example, if we were to raise the application going to production, it would be about the same time if you have a very, very agile environment. There is another option in case your organization is very, very sensitive to sharing the code in the cloud with us. There is another option to enable only metadata to be sent to the cloud. This metadata is a proprietary representation of the code in a graphical manner. It's the work of Fabian Yamaguchi. And basically, that metadata is all we need to conduct our analysis. So you don't have to share the code itself. So that's about it on the first integration point, which is uploading the code itself to the cloud. The second integration point is installing the agent in production. And this is very, very simple. If, for example, you have Java commands for running your application that looks kind of like this, all you have to do to run the agent as well is add this particular argument to your command, which loads the agent as the application is starting up. And then the agent communicates with the information in the cloud to understand the point that it has to instrument very surgically during runtime. So the agent is informed by the very analysis of this particular application, of this particular version of the application. So it is very, very precise in what it instruments or not instruments. So that's about it with the integration. At this point, you have code being uploaded every time you change it in our cloud. And in production, every time you deploy, the agent, micro agent of ShiftLeft starts up with the application and informed of the analysis will instrument the application and monitor its activity. So now you can take a look on your dashboard, on the ShiftLeft dashboard. And so this is the place where you would land. This is targeted to DevOps and security personas wanting to keep an eye on the security of the infrastructure and the applications. In here, we only have one application that we've onboarded. It's Hello ShiftLeft. It's telling you it has one instance is running. There's been a deployment a few seconds ago. And then these data categories in here would be, if you have many such applications in here, you can visually color match different data types that each application is using. So these might be things like sensitive data, passwords, or compliance or regulation bound data, infrastructure keys, medical data, and so on. Things that tell you a story about how sensitive is the application itself based on the sensitivity of the data it is handling. If we dive into the application itself, you now see the dashboard of the application. And let me just go through this item by item to explain what this means. At the very top, you have a throughput chart. And the throughput chart is a way for you to understand in context, how much traffic is the application getting. And now in the center widget here, this is the main focus of this dashboard. We are communicating to you that there is an alert related to sensitive data exposure. This has happened 7 minutes ago. So this is an application that I've started at the beginning of the demo, and I've hit it with some traffic to trigger the application. And this particular application is actually a minefield of problems, and it's leaking a lot of data. So in this case, as soon as I started it and hit it with traffic, this problem started manifesting itself. So if I go column by column, in here you see violations. Violations are individual problems in your application that we see. So this means there are 120 places in your code where you are leaking data. It doesn't mean you actually have leaked data in runtime. This is just communicating to you that there is a lingering problem in your application. The incident count, on the other hand, is telling you how much data has been leaked. And so in this case, already it's been 16,000 incidents. So like 16,000 variables have been leaked as part of this while the application has been running for a few minutes. Well, this is an extreme example, you would imagine, as this application is very problematic the way we have coded it. But it tells you, for example, out of these 120 violations, how many problems do you actually see in runtime manifesting itself, right? How many, for example, how many credit cards are you leaking? Or how many medical health records are you leaking? And you are bound by compliance, and you shouldn't be leaking them. The next column is the alerts. In here, we have color-coded alerts as red, yellow, and blue. So red is the most urgent, yellow is less urgent, and blue is even less urgent. And so in here, you see one alert for all of these incidents. We have an algorithm for collecting incidents in one alert to prevent alert fatigue. So the operator only has to look once, gets a single page, and can act on it rather than getting 16,000 pages for emails or alerts. If I go further in this section, you see sensitive data categories. In here, you see medical, password, payment data, and PII. This means that this application is handling this kind of data. It does not mean it's something wrong with it. It's just telling you a story about how sensitive is the application itself based on the sensitivity of the data it is handling. The way we detect whether something is sensitive or not is based on variable names. And so we understand from code analysis what kind of data you are exchanging based on the names of the variables you are setting in your code. And so if you have something called account number or account balance or so, we might understand that that is payment or banking data, and that is marked for detection during runtime of the agent. And as the application runs in production, we now track that kind of data to see whether you are leaking it or not in production. And that is how we figure out whether something bad is going on. On the left here, you see triggers. These are all the ways your application can be triggered from the outside. In this case, this is a web application. So it's a Spring Boot type of application if you're familiar with the technology. And it exposes a few web routes. So you see in here accounts and customers. And you see also the amount of traffic that each of these routes are getting. And so this is to put things more into context, more than anything. For example, routes like customers and save settings and search user already tell you a story about what kind of things this application is doing. This allows DevOps and security personas to better understand the application without having to read the source code, right? They haven't written the source code themselves. The dev team has. And now this interface allows them to quickly get up to speed with what this application is all about and put all these incidents into context. Other triggers we detect are things like RPCs, like gRPC and thrift, or asynchronous type of communication like queues or streams, so like Kafka or SQS and so on. Or if you have your own proprietary network protocol, it will just tell you, hey, there's a socket being opened, and this is the amount of calls you are getting through that socket. On the right, we have data destinations. This is a list of places that your data is going through. So this particular application is a bit simple, so it only logs information. So in this case, it's logging payment data. So in here, it doesn't immediately mean that something is bad if it's leaving the application. For example, you might have legitimate data that is being encrypted before leaving your application. And so even if it's sensitive, that is fine, right? You have taken the steps to protect your data. But in this case, I see this triangle here, which is indicative of a problem related to this data leaving the application. So if I go further, I click on this, I now get the variables that are involved with this particular data type. And so the variables in here are account number, initial balance, initial interest, routing number. And if I click even further, and now I get to the line of code in the source code where this particular problem started from. So this is the first time where a runtime tool gives DevOps and security personas the ability to quickly find the culprit of the problem in the code and give it immediately to the developer so they can fix it. In this case, this particular problem maps to this particular piece of code. It's saying that because of this initialization of the account construct, account number, routing number, and the account itself is being logged somewhere, it means that these variables are being leaked too. So immediately you see why this is a problem. Now another way to see things is through the interface of the alert view. And so in here you see this particular problem highlighted in red as showing up in here. This is more in a traditional form factor where it might be used to like a SIEM interface or line items of alerts being shown on the screen. So if that's the kind of thing you want to see, you can also see cross applications in here, or filter by certain types of problems that you want to see. Yeah, so I think that's about it on the demo side. I'll just switch now back to the slides.
Cool. Thank you, Vlad. So look, I think now that we talked about the demo, I just wanted to quickly sort of summarize where we are. one of the typical challenges that we've heard with a similar category of products called the runtime application self-protection, which doesn't really understand the code, but is only instrumenting the application to protect it, Gartner says that there are three key challenges with such tools. One, the friction is high to insert these tools. Hopefully, Vlad was able to show you that through the ShiftLeft plugin in the Jenkins-like environment. This is largely automated and perhaps 2-minute task. The second challenge that Gartner highlights is that if your application is using some APM tool, like let's say New Relic, and on top you try to instrument through a RASP, RASP will break APM. And that just logically makes sense because RASP is treating the underlying application as a black box. So it doesn't know what it should be instrumenting and what perhaps it shouldn't be instrumenting. And so if it sees New Relic, it probably tries to instrument that as well and breaks it. And finally, the performance impact of a typical RASP agent is, again, it just logically makes sense because it's trying to, for example, if your source code has 10 SQL queries, it's going to try and insert itself into each one of these queries because it doesn't know any better. We, on the other hand, through code analysis, understand that out of these 10 SQL queries, there are 2 that are vulnerable. And so as a result, all of this manifests itself in the performance of the ShiftLeft solution. Now, this performance metrics, or rather these performance metrics, will clearly differ based on the application. But notice that we are comparing the performance overhead of a ShiftLeft microagent with that of an APM agent. And as you can see, we are half to 1/10 in some cases the performance overhead of a typical APM agent. And given that RASP is usually an order of magnitude worse than APM, we are significantly better than a typical RASP solution. And again, it just logically makes sense. Why? Because we understand code and therefore already know where we should be instrumenting ourselves. So in summary, why ShiftLeft? Well, first of all, agility. The world is getting ever faster. We are using, or we are, deploying and developing software ever faster. And in that world of pace, that pace of change, you need to rethink security. And a solution like ShiftLeft, as we've shown, is extracting the security DNA every time your software changes. For us, it doesn't really matter, even if you change your software 30 times a day. Within 5 minutes, we will give you a custom, bespoke security solution for your software agent. Cloud agnostic. Look, one thing that we haven't talked about is we are essentially, given that we support Java initially, we are instrumented into your Java virtual machine. And that is the only common denominator for us. Meaning you could run this Java virtual machine on Linux or Windows, in AWS or Azure, in containers or virtual machines. We are agnostic to the underlying infrastructure. Encryption doesn't defeat us. Inter-microservice communication is increasingly encrypted. Everything is going HTTPS. And so all the traditional security tools are going to require man in the middle, give them private keys, et cetera, et cetera. So the complexity is just getting layered on top of the other. By looking at what the application sees, we are completely agnostic to how you deal with encryption. We protect the application, as we talked about earlier in the slides. That is the one thing that SaaS vendors, or if you're developing software and you're hosting the software for the consumption of your employees, that you need to worry about. Remember, the network and this operating system is increasingly owned by the cloud provider. Remember the shared responsibility model. Not threat focused. Not threat focused. So this seemed like a daunting task to us when we started more than a year ago, but it is very exciting to see that we finally have come up with an approach where we don't need to worry about threats. We worry about the weaknesses that are inherent in your application. And finally, a very important aspect that customers are giving us a lot of positive feedback on is this ability to identify the line of code that causes the issue at runtime helps us significantly reduce the mean time to repair. I mean, just think about how the world works today. If your SOC is monitoring your application in production, you will probably see an alert. You will then give it to the QA team, which will probably try and recreate the scenario. And once they've successfully recreated it, then they'll give it to engineering, who will then have to go find in the code where such a behavior might be taking place, right? We are short-circuiting all of this, which might be taking days to weeks, depending upon the organization, into minutes by telling you the line of code that causes this issue. Great. So we are at the end of the discussion. I think one question that we already did get, we'll try and answer.
Yeah, so I see a question from Victor Chin. Does ShiftLeft integrate with GitHub, GitLab? If not, is it on the roadmap? We do not yet today integrate with these systems, but we do plan to do so in the future. One more alternative to the Jenkins plugin is also our CLI. So if in conjunction with GitHub or GitLab, you're using maybe Travis or Circle or some other CI tool, the CLI of ShiftLeft is also another way to upload your code for analysis. So you have that option, which is equally easy to use. No.
So there's one more question, which is, can you share the deck with us? I think perhaps what you do is go to shiftleft.io, and there'll be a contact information, and the recording of this webinar will be available on our website, and so yeah, you can access it there. So the third question that we just received is, do you have a security white paper on your product? Yes, again, if you go to shiftleft.io, under the white papers, there's a white paper that provides a detailed overview of ShiftLeft and how it works, and how the two aspects of what we do, which is code analysis and runtime protection, are brought together for the first time in the industry.
If you have more questions, feel free to enter them in the
this chat box
named questions.
So Victor Chin, has the code analysis instrumentation been tested with ephemeral compute such as AWS Lambda?
We have not yet started on that, but this is relatively easy to integrate as well. So Lambda allows you to basically to abstract all your infrastructure away, and so it's pretty natural for us to gravitate around that technology as well.
And I will say the following, which is, again, if you go to sort of shiftleft.io under the collateral or the white papers link, there is another IEEE paper from our chief scientist, Fabian Yamaguchi, which talks about the code property graph concept and how he uses that approach to find 18 zero-day vulnerabilities in the Linux kernel. So to the broader question of, look, does your code analysis work and has it been tested? And this was done, Fabian did this in 2015, right? And as we all can acknowledge, the Linux kernel is a pretty complex beast. So to find 18 zero-day vulnerabilities in it is quite an achievement and a validation of the code property graph approach to look for defects in code.
All right.
All right. If there are no other questions, on our website there is a try now, and so you can definitely, go to the website if you want to try this out on your own. We are trying to rethink as to how security solutions should be tested and bought, right? I mean, traditional security solutions is that you talk to the salesperson, schedule a proof of concept, something gets shipped to you, et cetera, et cetera. We are saying, no, let's make security a self-serve, try and buy approach. So you can come to our website, and initially you don't even have to submit us your code. There is this Hello ShiftLeft application that we've made as part of GitHub, and you can change that. You can add lines of code into it, and we will analyze it, and we will give you, we will show you how that application behaves in production. Or of course, you can submit us your code, and we will give you the entire solution that Vlad just talked about, and you can experience it. You can try it before you decide to buy it. All right, well, if there are no questions, again, truly appreciate you all dialing in and giving us your precious time. Hopefully we were able to convey both the industry dynamic and why this is the time to sort of rethink security and stop reacting to the threats, because all that has gotten us is spy novels like environment where we get to chase bad guys and constantly keep chasing them. For the first time, we can think about security from first principles and understand the security needs of the software and create a custom solution for it every time it changes. And that is the promise of ShiftLeft. So if you are truly interested in protecting your software, contact us. With that, thank you. Bye-bye.